Hey everyone! Ever since Ethereum was introduced in the blockchain space with its presence in 2015, new decentralized applications have been developed by Vitalik Buterin. However, smart contracts are a big part of Ethereum's success. These new contracts are referred to be smart contracts since they are significantly more functional than their paper-based predecessors. There is no mention of AI. A smart contract is a set of digital agreements that include protocols for the parties to fulfill those promises. So, considering its popularity and uniqueness, I, from Simplilearn, have brought you a new video on how to create an Ethereum smart contract. So without any further delay, let's get started with the video. But before starting, please do subscribe to our YouTube channel and hit the bell icon to never miss an update from Simplilearn. So let's start with the coding journey to our first Ethereum smart contract. But before diving into the development and deployment of Ethereum smart contracts, it's critical to first grasp the Ethereum platform and how it functions. So the first thing that we learn is what is smart contract in the first place. So smart contracts are essentially programs that run when criteria are fulfilled and are stored on a blockchain. They are usually used to automate the execution of an agreement so that all parties can be certain of the results right away. So without the need of any intermediaries or time waste. They can also automate a workflow starting the following step when certain circumstances are satisfied. So now that we know what is smart contract, let's move ahead and see how it works. So step 1, smart contracts are made up of basic if, when, then phrases encoded in code on a blockchain. Step 2, when preset conditions are satisfied and validated, the activities are carried out by a network of computers. These measures could include sending notifications, releasing funds to the proper persons, or issuing a ticket. Step 3, when the transaction is completed, the blockchain is updated. That means the transaction can't be modified and the results are only visible to those who have been granted access. There can be as many stipulations as needed. Convince the participants that the task will be executed correctly. Participants must agree on how transactions and associated data are represented on the blockchain. Agree on the if, when, then rules actually govern those transactions. Investigate all conceivable exceptions and design a framework for resolving disputes in order to set the terms. The smart contract can then be coded by a developer. The firms that use blockchain or business are increasingly providing templates, web interfaces, and other online tools to make smart contract construction even more easier. And here also we will be using one such tool to create our very first Ethereum smart contract. So now that we know all the required knowledge about smart contract, let's start with how to create our very first Ethereum smart contract. So let's get started. Now let's start with the first smart contract. So the first thing that we need to do is to navigate to this website, which is remix.ethereum.org. So this is going to lead us to a Remix IDE, as you can see, which is an integrated development environment for Solidity programming. And it runs from the browser itself, so it does not need to be installed and you can access it in any operating system. So it's a lot more convenient, and you can also use it to interact with the Ganache or testnet over RPC port. So basically RPC or remote procedure call interface is provided by the blockchains for the execution of the functions that you'll store or that you'll insert as a criteria in your Solidity smart contracts. So here we will be using Ganache to deploy our smart contracts. So let me give you a quick introduction to Ganache. Basically, it's a personal blockchain that enables the building of Ethereum and Coda distributed applications quickly. And it may be used throughout the development cycle, allowing you to develop, deploy, and test your decentralized applications. in a secure and a very predictable environment. But before deploying our smart contract on Ganache, we will deploy a smart contract on the default blockchain provided by the remix itself. So let's get started with the code. So the first thing that we need to do is to create a file with .sol extension. So you can see here I have already created my workspace with the name of demo smart contract workspace. Now I just need to create a file. You can click on this icon and you can give it a name according to your convenience or whatever program you're gonna store in your smart contract. So basically .sol is the extension to our smart contract since we are using Solidity programming to create our smart contract. So I'll just give it a name. So here I have given it a name called democontract.sol and that is it. Now you can see here you have directed to a section where you have to actually write your code. So basically in this video, we will be creating a smart contract for the implementation of cryptocurrency in its most basic form. So this smart contract will allow you to create or mint new coins and send them to other blockchain addresses. So let's start with the code. So the first thing that we will write is pragma directive. So let's write pragma solidity 0.5.1. So this is basically a range of our minimum margin for our Solidity server. Then we will declare the contract. So let's just write contract. So basically the contract code starts with a keyword, the contract followed by the name of the contract according to your convenience. So here I am giving it a name mint your coins. And then the braces, which employ the entire contract state and its functions. So now that we have declared our contract scope, let's start with the variables and functions that we need to declare in our smart contract as per our need. So here I am declaring our variables. So the first variable is for addresses. The first one is minter. And second is balance. So these are known as state variables, or this mapping can be thought of as hash tables that are virtually initialized so that every potential key exists right away and is mapped to a value with a byte representation of all zeros. So this map will store every address with its balance. So now that we are done with the declaration of our variables, let's create a constructor that will be the address for creating new coins. So constructor, we'll make it public. Minter dot msg dot sender. So this line ensures that only the creator can mint new coins. Next, we will set a condition for creating new coin and storing them in the hash table. So now to store our created new coins into a hash table, we'll declare a function mint. So let's start with the code. Function address of the receiver and the amount to be received. We'll also declare this public, and we just need to mention our conditions here. So this is our first condition. Second, we'll mention a limit for the maximum number of coins to be created, or for the maximum number of, the amount to be received or sent. This is done. So the next function is going to be sent, which simply examines the transaction's feasibility. So let's declare that function as well. So again, let's input our parameters, address of the receiver, and the amount. We'll make this function public as well. Mention our criteria. So the first one is this is for you to check if there's sufficient balance or insufficient balance in the account. So if the transaction is possible, the function will generate a sent event. So we also need to mention an event here. To know all the details, like who has the address of the sender and the receiver, as well as the amount. So here we have created the event. Now let's get back to the criteria in our send function. So as I was saying, if the transaction is possible, the function will generate a sent event, which is a declaration for the transactions to be broadcasted. So let's just get done with our criteria here. Amount. So the clients using Ethereum can listen to these events on the blockchain for free. The listener receives the arguments from or to an amount as soon as the event is emitted right here in the send function. Sorry, I forgot to mention too. Yeah. So as soon as the event is emitted, the transactions is tracked, and then the next function is executed, which is to get the balance of the address. Also, when the transaction is completed, the transaction is then added to the blockchain itself with all the data of who has sent those coins and who has received it along with their addresses. So let's create one more function to know the balance. So that will be, let's give it the argument external view returns. For the return value, that will be integer. Return balances, the argument we just mentioned. So this function is to get the balance of our account. So this was our code. Now we need to compile this code, see if there is any error or not. So to compile this, you need to click on this icon and just click on compile. So here you can see that there is no error and it's successfully compiled. So once it's compiled, you need to deploy this code. So click on this icon. Here you can see this is the by default environments provided by Remix itself. So here we will just select the default one, JavaScript virtual machine. So like we discussed before deploying our smart contract over Ganache blockchain, we will be deploying it over the blockchain that is by default provided by Remix itself. So here we have selected the environment. These are the accounts with the dummy coins already stored. Obviously, you can't use them for your actual purposes, but these are the dummy accounts provided by the Remix for analyzing your smart contracts and keeping the track of the transactions. So you can simply select any of these accounts according to your choice. And as you can see, there is currently no contract deployed here. So simply we'll just click on deploy. So here you can see it's successfully deployed. We'll just click on this drop down menu, and after scrolling it down, we can see all the options with the functions like mint, send, balance, balances, and the minter. So when you click on minter, it will generate an address, current user's address. So just copy it. So once you have copied, you can just click on balance. So here you can see you're getting error because right now you have not transacted any amount of coins yet. So we'll just paste the address here and then provide the second argument, which is the amount that you want to mint. Just click on mint, and here you can see its success. You have successfully minted 500 coins. So now when you check the balances, we are still getting error. Sorry, I forgot to provide the address. So we'll just provide the address and click on balance. Here you can see the function is already called, and here you can see the amount you just minted. Same as for here. Click on it, the amount you just minted. Now to send, you can just click the address, comma, 250. So for demonstration, I have provided the address of obviously the sender right now because I don't know the address of the receiver. But what you can do is you can provide any other address and just put the amount and click on send, and when you'll check the balance, there will be a change in it. Right now, there is no change because both the addresses are already same. So this was all. This was the code, and this is how you can just compile and deploy your code on any blockchain. So now that we have checked it over the default blockchain provided by Remix, let's have a look at the Ganache one. So to use Ganache, you need to first download it. So by clicking here, you can just download it for Windows. So I have already installed this, so we'll just jump to that step directly. So once you're done with the installation of Ganache, you'll get a page like this, and then you have to create a workspace. So you don't need to create a workspace here. You can simply click on Quick Start and it will give you a list of accounts and all the details of the blockchain that you can simply connect with your IDE and to which you can simply deploy your smart contract into. So let's just wait for it to download all the information. So now here you can see all the default accounts provided by the balance information by the Ganache itself. What we need to focus on is RPC server. So basically this is the address provided to every Ganache account or blockchain by default itself. So we just need to copy this and click on Ethereum IDE and go to the environment and select Web3 provider. So when you'll click on it, you'll get this pop-up, and at the end point, you have to paste the address you copied from your Ganache portal and just click on OK. So now you can see again there is no contract deployed to it because now you're simply connected to the custom network, which is your Ganache network. Now these are the accounts provided to you by Ganache itself, the list of accounts that you saw on the portal. Now the same process you need to repeat here. Just click on any account of your choice, select it, and click on deploy. So here you can see it's successfully deployed, and again we're going to repeat the same process. So you can see the address is completely different from the previous one. Just copy this, paste it here. Let's have a different amount this time. Let's put it 750. So, and just click on mint. You can see it's successfully minted, and when you will paste the address here and click on balance, you can see it's showing 750. Same you can do for balances. Click 750. And the same you can do with the sent also. As I'm using the same address, there will be no change in the balance. But obviously it's not popping any error and showing it's successfully done. So you can use it with somebody else's address too. So this was all about your first own created smart contract. I hope you enjoyed this video and learned something new from it. Please do like this video, and if you have any queries related to this topic or this video, you can simply comment down in our comment section. Our experts will reach you out as soon as possible. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.